Welcome back to another math video here at Math Rocks with Mr. Cox. Just so you know, this is a continuation of part one in which we were looking at how to find roots of polynomial functions. And in this video, we're going to be looking at fourth degree polynomials, so 1 degree more. Here's a graph of this function up here. And you'll notice, although it's a fourth degree polynomial, there's only 2 real roots down here. So the question is, well, what happened to the other 2 roots? Because we know we need to have 4 altogether. Also, we're going to be taking a look at how do you narrow down your search. And so, for instance, could x equals -3, could that actually be a root? Or what about x equals 4? Or x plus 2, could that be a factor of this function up here? Or what about x minus 5? So we're going to be looking at a thing called the Rational Root Theorem to discover the shortcut for how to kind of narrow down our search of what possible roots and factors might be. So stick around and you'll find out how all this works. Let's get it on! Let's first take a look at how to kind of narrow down our search here. And there's something called the Rational Root Theorem that says the possible rational roots are plus or minus, and then we have this fraction over of the factors of the constant divided by the factors of the leading coefficient. So I know that's a lot of verbiage and it might be a little confusing right now, but the constant is the number on the end here. So the constant is 6, and the leading coefficient is, find your highest power, which is x to the 4th. The coefficient here is 1. So what this would be is you would take the factors of 6, and then what you would do is you would divide by the factors of 1. Well, you have to ask yourself then, what are the factors of 6, and also what are the factors of 1? Well, for 6, it would be 1 and 2 and 3 and 6. And the factors of 1 are easy. There's only 1. It's 1. So basically it'd be 1 over 1, 2 over 1, 3 over 1, 6 over 1. So the possible roots that are rational would be therefore plus or minus 1, plus or minus 2, plus or minus 3, and then finally plus or minus 6. So this can help narrow down our search. So we don't have to look for does 5 go into this, or 4, or things like that too, or what about 1/2? It's just going to be one of these 8 possible rational roots could be the ones that would be the winners for us. Well, what if the constant in this case is 8 and now the leading coefficient is 2? So now we'd be looking at all the factors of 8 divided by the factors of 2. So the factors of 8 would be 1 and 2 and 4 and 8. And then the factors of 2 would be 1 and 2. So first we're going to have everything on top divided by 1. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, and then plus or minus 8. So these are going to be all possible rational roots that could go into this function here. Also, we would take each of these factors, 1, 2, 4, and 8, and divide by 2. So we'd have 1 over 2. So I'm going to write plus or minus 1 over 2, which is a half, obviously. I have plus or minus 2 over 2. Now, I don't really need to have this one because what is 2 over 2? Well, that's just 1, and we've already included over here. So I'm just going to go ahead and cross that off. We can also have plus or minus 4 over 2. So I'm going to write plus or minus 4 over 2. Well, that's also going to be equivalent to 2. We already have that, so I'm going to cross that off as well. And then we also have plus or minus 8 over 2. And that is going to be equal to plus or minus 4, and we already have that over here, so I can cross that off too. So therefore, these right here are going to be our possible rational roots that we can now use to search to find all the roots and the factors as well. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. Now let's go ahead and see how this would come into play here with this function here. So using the Rational Root Theorem, we would take the factors of 15, which are 1 and 3 and 5 and 15, and we would divide each of those by the factors of the leading coefficient, which is a 1, so that would be a 1. So really what we have here is we have plus or minus 1 could be a possibility, plus or minus 3, plus or minus 5, and then finally plus or minus 15. So what you would need to do is just really start guessing. So what I'm going to do right now is I'm going to start with 1. I'm going to start with a low number here. So if 1 was my root, that means x minus 1 would be my factor, okay? That would mean my root is equal to x equals 1. So I'm going to divide it into here and see what happens. So I'm going to go ahead and I'm going to make my box here. And once again, I'm not the best box drawer, but you get the idea here. And I'm going to need 4 of them. I always need, if this is 5 terms, I'm going to need 4 boxes going sideways here. And I'm going to go ahead and I'm going to put my x minus 1 right here. So I'm going to take my highest power, x to the 4th, slap it in right over here. And I have to ask myself, x times what is x to the 4th? Well, that would be x to the 3rd. Negative 1 times x to the 3rd would be negative 1x to the 3rd. I know I need a total of negative 2x to the 3rd because it says so up here. So I'm going to have to put another one down over here. So remember, these two combined, when we add them together, would be negative 2x to the 3rd. X times what gives me this? Well, that would be negative x squared. If I take negative 1 times negative x squared, I get positive 1x squared. I need a total of negative 6x squared. I was already thinking ahead there. So therefore, I'm going to need a negative 7x squared here. X times what gives me this? Well, that would be negative 7x. Negative 7x times 1 would be 7x. Together, I'm going to need 22x altogether. So that means I'm going to need another 15x over here. X times what gives me this is 15. And then finally, if I take my negative 1 times 15, I get negative 15. And what do you know? It's a match. In other words, my last constant here matches the constant there. So now I know that when I divide x minus 1 into this 4th degree polynomial here, I'm going to get x to the 3rd minus x squared minus 7x plus 15. All right, so from here, what we're going to do is we're only going to look, we know that x minus 1 is already a factor. We're only going to look at what was left over, x to the 3rd minus x squared minus 7x plus 15. So we'd have to start guessing some other things here. So I'm just going to go ahead right now and I'm going to say, let's say I want my root to be, say, x equals 3. That means I'm going to need a factor of x minus 3. So I'm going to do it again here. I'm going to go ahead and draw my box. And when I do this, I have 4 terms here, so I'm going to need 3 going this way. I'm going to write my x minus 3 on the side over here. From here, what I'm going to do is I'm going to drop down the x to the 3rd right here, my highest power. X times what gives me this? Well, that would be x squared. Negative 3 times x squared is negative 3x squared. I'm going to need negative x squared altogether. So that means I need a positive 2x squared so that these two will add together to be negative 1x squared. X times 2x would give me this. 2x times negative 3 is negative 6x. I'm going to need a total of negative 7x. So that means I need a negative x here, which means x times negative 1. And if I take my negative 3 times negative 1, I get a positive 3. And you'll notice, wait a minute, that doesn't match. So unfortunately, x equals 3, although it's a possible root, it's not actually going to be a root. So what if instead I wanted to try x equals negative 3? That means I'm going to look at x plus 3 and see if that works. So let's try that right now. So I'm going to go ahead and make another box here. 1, 2, 3. And I'm going to put my x plus 3 over here. So let's see what happens here. So if we were to do that, I'm going to drop down the x to the 3rd right here, like we were doing before. X times x squared gives me that. X squared times 3 is 3x squared. I need a total of negative x squared, so I'm going to have to do a negative 4x squared. Once again, I need these two to add up to be negative 1x squared. X times negative 4x gives me this. Negative 4x times 3 is negative 12x. I need a total of negative 7x, so I'm going to put a positive 5x here. So these two will add up to be negative 7x. X times 5 will give me that, and 5 times 3 is 15. So this is a winner. So that means we have one factor already of x minus 1 and another one of x plus 3. And then it's also times the quantity x squared minus 4x plus 5. So now that we know that, we're going to take a look now at this last polynomial, or x squared minus 4x plus 5, and this is not factorable, so we're going to do the quadratic formula. So therefore, a is 1, I know that b is negative 4, and I know that c equals 5. So let's go ahead and work the quadratic formula here. So I get x equals, I take the opposite of this, which is going to be 4, plus or minus, I'm going to square b. Well, if I square negative 4, I get 16. And then it's minus 4 times a, which is 1, times c, which is 5, all over twice a. Well, if I double 1, I get 2. Now, if you grab your calculator and do the math, 16 minus 4 times 1 times 5 actually is 4 plus or minus the square root of negative 4. All right, so, oh my gosh, we have the square root of a negative number. So you should know imaginary numbers right now, and so this is equivalent to 2i. So now we get 4 plus or minus 2i all over 2. And you should notice now that, oh my gosh, these are all divisible by 2. They're all even numbers. So I can have 2 plus or minus 1i all over 1, or just 2 plus or minus I. So when we're all done here, if we had to describe the roots, over here, this one factor gives us a root of x equals 1. This factor would give us a root, once we set this equal to 0, of x equals negative 3. So right now we have 2 real and what we call rational roots here. And those were some of the ones that were possible. And once again, even though they're possible, it doesn't make them going to be a root, but at least narrows down the search for us. So we have 2 real rational roots. And over here, these 2 roots would be what we call complex numbers. So we also have 2 complex roots. And remember from earlier videos, complex is nothing more than, it's a combination of what we call a real number, like 2, and then we add or subtract an imaginary number to it, and that's what makes it complex. So that's how this all works. You can see that using a 4th degree polynomial, it's going to require a little more work here to get to the end, but it can be done using polynomial division. And once again, also the rational root theorem helps us narrow down our search, so we're not looking at every possible number we can think of. We're only thinking of some numbers and some factors that we can use to actually find the answer. Hope you got a lot out of this video. Thanks for watching.